So like I said, Dan is joining us from Boulder, Colorado. Dan is the head of developer relations at FusionAuth. Um, and so he's here to tell us what we need to know as Rails developers in JWT. Welcome, Dan.
Oh, welcome. Thank you. Let me share my screen real quick. All right. So thank you for having me today. I really appreciate the chance to come and talk to you. And this is my first time using this tool, so I may be a little bit of kind of going back and forth, whatnot. But cool, Tomer. Yeah, Boulder's a fun place for sure. So what we're trying to talk about is JSON Web Tokens, or JWTs. Real quick about my employer, FusionAuth is a drop-in user data store. It has an offering you can pay for, but also has a community edition that is free as in beer, which supports OAuth grants, SAML, passwordless, social sign-on, consents. So you can manage consents and understand what those are, whether those have been granted to you by users, and a whole lot more. And how that's germane to this presentation is two things. First is they're paying for me to come talk to you, which is, I appreciate that. And the second is that we produce a whole lot of JWTs, or JSON Web Tokens. So that's what I'm going to mention about FusionAuth. You could check it out and download it and get a user identity store up and running in about 5 minutes. About me, who cares? You didn't come here to learn about Dan Moore. You came here to learn about JWTs. So let's kind of jump into that. I would say a bit of housekeeping. If you have questions, I actually have things arranged so I can see the chat right now. If I lag, please tell me, because I'm a bit far away from my Wi-Fi router, and so there may be issues with my voice or whatnot. So if I lag, please tell me, and I'll go back to that slide or whatnot. Again, thanks for having me. So let's talk about JSON Web Tokens, or JWTs, briefly. They are a standard, so the IETF standardized them in that RFC. If you want some bedtime reading to put you to sleep, go ahead and check that out. But basically, they're a JSON object that can be encoded and tends to be used for a portable, stateless representation of identity. And that could be authentication, it could be authorization. It's really great for APIs because you can take this generated JWT and hand it to a client, and the client can present that to different APIs who can examine that JWT and know, oh, Dan's allowed to do this action, he's not allowed to do that action, without going back and talking to the identity provider. It is produced by a lot of IDPs, FusionAuth, Auth0, Okta, all those produce JWTs. And it's important to note that they are base64 encoded. So that's really nice because you can have JSON out URL or new, because it all gets turned into a encoded string that can be put into headers or form posts or whatever. So let's talk a little bit about a typical application that you might be building. And so what we have here is we have clients over here, a web browser, a mobile application. We have different APIs. The user API talks to the user data store. The to-do API talks to the to-do data store. And there's kind of three things to really think about that I want to really kind of call attention to in this slide. The first is that these clients have no ability to keep your API keys secret. So that means that if you encode an API key into those clients, you're going to, eventually someone's going to decode it, right? They're going to look at the JavaScript. They're going to look at the native code, and they're going to be able to extract that API key. So that was the second point. If you don't care about whether or not your APIs are secured, then, go ahead and embed those API keys. If you do care about how those APIs are secured, you need to come up with some other way of doing authentication authorization other than the API key. And the third point is, right now we have a user API and a to-do API. You could imagine that as your application grows and gets more features, you might add other things. A to-do API, I'm sorry, a to-do reminder API, an email API, some other pieces that you would kind of add in to build more features. And how you design your JWTs depends on who owns those various APIs. Do you have these all kind of contained within one organization? Do you have other people or other organizations that are going to be building APIs that might leverage your user API or your to-do API? Those are all things to consider. And we'll dive into those a little bit deeper as we go on. So, all right. This is the schematic of the user API. Pretty typical. You have a users table, you have a user roles table and a roles table, and you basically are managing kind of everything that a user might have within this API. So any additional user data, mobile phone number, the roles that they have within your application or applications. The to-do API is pretty simple. Basically, it just is a wrapper around the to-do table. And this is what the table might look like in a relational database. You might have an ID, text, I might add this, you might augment this and have like a title for the to-do or whatnot, but it really keys off of the user ID. It has a foreign key of the user ID, basically. So how the flow basically works for this application is you have a client that is going to post to an endpoint against the user API to log this user in. And they're going to typically provide a username and password, although there are other ways you could actually authenticate a user. And they'll get back after the user API looks in the user's table, verifies that this username and password matches up with a particular user 42. They're going to get back this user as a JSON object. And what that JSON object might look like is something like this. So it might have an ID, it might have my name, email address, other information about me, and then roles that I have for this application. So that JSON gets passed back to the client. The client stores it off, and then the client can now present that user object to the to-do API or other APIs. That to-do API can then look up the to-dos for this particular user and then hand that back to the client. So the issue is with this particular kind of naive implementation is that I, being a malicious client, might say, that's interesting. I am passing in the user ID of 42 and I get back my to-dos. What happens if I pass in different IDs? 1, 2, 3, 4, right? I have a sneaking suspicion that there might be IDs under 42 based on what I understand about databases. So that's obviously bad. Something like Dan has to go get milk is very, very important data that should be, as Benjamin mentioned, should be secured, right? Or Benjamin didn't mention that. He mentioned security is important. I want to make sure that no one else knows that I'm going to go get milk today, for example. So let's think about a way to solve that problem that doesn't let a malicious client kind of iterate the IDs. So what you could have happen is you could have the user API generate an opaque token, represented here by that gray T. And that token could just be a random string of digits or alphanumeric characters, doesn't really matter what it is. The point is that it can't be iterated easily. So the token gets passed to the client stores that token off and then presents it to the to API. The to API then talks to the user API and says, hey, give me this user that is represented by this token. And then the to API yeah. Just going ahead. This one is chat. And yeah, and look the. Oh man, I'm sorry. Sorry. Um, let me reposition. Is this better now?
And the co-hosts are really great too.
All right. And
Yeah,
you
it
hear me
sounds
now.
good. I think the last thing, at least that I heard, was that you started to talk about the gray authentication token.
Great. All right. All right. Thanks for letting me know. So yeah, so let's kind of we'll just start the slide from the beginning. So the nice thing about using an opaque token that the user API generates, that could be an alphanumeric string, it could be just a string of digits. Doesn't matter really what it is. The point is that the user API generates it, passes it to the client stores it off, doesn't have any way to iterate that token to find out information about other users' to-dos, but the client basically just passes it to the to-do API, which then says, oh, I have this opaque token, I'm not sure what to do with it, but I know I can go talk to the user API and get back information about this user. And so the problem with that, I mean, the solution, the good thing about that is that it means that the user API, the client can't really do anything nefarious with that token because it just is a random string of digits that only has meaning to the user API. The bad thing about it is that it makes the system very chatty, that basically any API that needs to know anything about a user is going to have to talk to the user API. And that has some negative ramifications in terms of just scalability, and it makes your user API kind of a single point of failure. So this is where JWTs come in and present as a good solution. So instead of generating an opaque token, the user API can generate a JSON Web Token and pass that to the client. And again, the JWT is not, I mean, it can be looked at by the user, by the client, but it doesn't actually, it's not intelligible to it, right? You can't look at a JWT and say, okay, I know that user ID 42 is here, so I'm gonna look at user ID 1 or 2. So anyway, that JWT gets presented to the to-do API, and the to-do API can now examine and decode that JWT and look at the contents of it without ever talking to the user API. And so that lets the to-do API be independent to some extent of the user API. So JWTs have some other kind of beneficial properties. In some situations, you can actually have the user API sign them with a private key, and then the to-do API can validate that they were signed by using the public key the user API provides. They can contain arbitrary amounts of information. Basically, anything you can put in in JSON object, you can put in a JWT. One thing that's really, really important to emphasize is that you don't want any secrets in a JWT, because basically anybody who sees a JWT can, let me put it this way, they are cryptographically signed and they're encoded with base 64, but they're not encrypted. So that means that anything you don't want on a postcard, you wouldn't write on a postcard, you shouldn't put in a JWT, because anybody who gets a hold of it can decode it very easily and see what's in there. So let's actually look and see what a JWT looks like. So here is a valid JSON Web Token, and there's three main components to it. The first in green is just a header, which specifies some information about what algorithm was used to sign the JWT, and other kind of metadata. And then we have the blue, which is the payload, and then the tan, which is the signature. And we'll kind of dive into each of these pieces a little bit more. So here's the header. And in this particular case, the header only has one key, and that is, or sorry, one value, key value pair. And that is the algorithm that was used to sign this JWT. In this particular case, it was a symmetric signing algorithm, HMAC, with 256 bytes. Here's the payload. And so like any other part of computer science, JWTs have a certain amount of jargon. And so the keys of this JSON object, the ISS, EXP, AUD, those are all called claims. And so there's three different kinds of claims. There are private claims, which are claims that you kind of define yourself that aren't standardized. There are public claims that are part of the RFC. And then there are registered claims, which are basically registered someplace that aren't part of the standard, but are, everyone has kind of agreed that they're semantically, that they mean the same semantic thing. So I'll talk about kind of what each of those types of claims, what are examples of each of those types of claims are. So let's look at this payload in more detail. The ISS is the issuer of the JWT. So that is the identity provider, the user management store, again, like FusionAuth or any other one that generated this JWT. You also have the expiration date, and that is a UTC timestamp in seconds. And that is a time beyond which this JWT should not consider to be valid. And so you should be checking that every time that you see a JWT as an API consumer. You also have a audience, and this is a way of saying who this JWT was created for. So you can imagine if you have a to-do API and a send email API, you may want to control access to those in different ways. And so what you can do is the identity provider, the user API, can say, I'm generating this JWT. It's only supposed to be for the to-do API. It's not supposed to be for the email API. And so if the email API gets this particular JWT, it should ignore it because it wasn't the designated audience of it. The sub claim is basically an identifier for who this JWT is about. So it's basically like a user ID. And then those four are all public claims. So those are all kind of standardized in the RFC. Name is a registered claim. So everyone's kind of agreed that name should be about a name of the subject. And then roles are a private claim. And so you can have as many private claims as you want in here, and that they can be really tuned to your business domain. Here's the signature, and you can sign JWTs in a variety of different algorithms. So RSA is a symmetric, or sorry, RSA is public-private, HMAC is symmetric, elliptical is public-private cryptography. And the thing that the signature does is it basically means that you make the signature against the contents of the JWT, including the header and the payload. And then anyone who's consuming it can verify that this JWT has not changed as it's been sent over the wire. I want to just emphasize that again. The signature is not encrypting the JWT. The JWT is totally in plain text. And if you see a JWT, if you cut and paste this JWT from my presentation into any one number of open source JWT debuggers out there, you can see the whole contents, except for you'll see the contents of the payload in the header. But the signature means that you can be sure as a consumer of this that it hasn't changed over the wire. So finally, we get to the point where we can actually get the to-dos, right? We have generated the JSON Web Token. We've sent to the client. The client has sent it to the to-do API. The to-do API has looked at those claims and verified that this JWT is not expired, that I'm part of the audience for this JWT, that this person has the roles that they need to have, and I'm going to go ahead and find all the to-dos for this user. Awesome. So any questions about JWTs so far? Because I'm going to kind of step away from them and kind of talk about some of the different aspects of them going
so Ben Greenberg had a question. I always call them JWT, not JWT. Is JWT more common?
You know, I was told JWTs is what my boss and people who've been living in this world a lot longer than I have told me. I don't think you're gonna get dinged if you say JWTs, but
yeah. I also I only started
me.
hearing JWT like a couple of days ago, and then when you came on, started calling it JWT. I was like, oh man, I'm showing how green I am. I had a second question. Maybe I missed it or something, but have you handled how? Did you talk about how the JWTs? You talked about this problem with like the general token. Sorry, I'll turn my camera on. You talked about this kind of problem with like a general token, in that it's too chatty. But how does the JWT, like, I guess because it sends all the information it needs to, like that way there's no chattiness problem, if I understand correctly. But and you said like all the information in the JWT is like a postcard, right? But how do you keep that level of secrecy of the stuff that you don't want on the outside of the postcard?
Sure. So that's a good question. So what I would say is that you want to send just what you need. And so if we look back at that payload here, you know, none of this stuff is either kind of stuff that you would probably know anyway, right? Like Dan Moore is probably pretty common knowledge. You know, the issuer is pretty common, or it is something that is identifier that's kind of opaque, right? So you can see that the odd or the sub claims are not integers because that might leak some information. And so those are just GUIDs. And it's gonna be really hard for anybody to like iterate those GUIDs to like determine anything else about kind of the innards of the number of users of this application, for example. You know, I mean, the meta answer to your question is you have to be conscious and careful on what you send. And if you do have some information that you need to get from the user API to the to-do API that you don't feel comfortable putting on a postcard, then maybe the answer is to pass in the sub and then have the to-do API contact the user API, right? And maybe that doesn't have to happen on every call. Maybe it only happens on situations where you're deleting a to-do or something where you're doing kind of a more elevated bit of data manipulation. Or maybe the answer is JWTs aren't the answer to your problem, right? I mean, I'm not here to say that JWTs are like magical unicorn fairy dust, right? They definitely have their place, but they're not every solution, every problem. Does that answer your question, Benjamin?
I don't know if you wanted to save more questions to the end, but Ariel asks, I've seen that Ori, if I mispronounce that, sorry. I've seen that Ori Hydra recommends the use of opaque tokens due to the no secrets issue. Is this a common pitfall where people accidentally expose information in a JWT?
I don't know how common it is. I haven't seen any numbers on that, but I do know that it's something to be aware of. So, I mean, the opaque token is it's a series of trade-offs, right? And this gets back to kind of what kind of system are you designing? If you are like if you're building this little application and you have different APIs, but they're all within the same Rails application and all sharing the same database, then opaque tokens might be a really good fit, right? Because it might be just looking something up in a database as opposed to a network call, and so the chattiness doesn't matter as much. But if you're starting to build bigger distributed systems, and especially if you have a system where you want to allow somebody else, like you have organization A building the user API, and you have organization B building the to API, and you want them to be able to communicate, suddenly network chattiness becomes much more of an issue. So where are the questions being? Are they just sent to the host?
Yeah, there's a Q&A tab on the far right. It's Jorge saying he's having a problem with the sound, but I hear just fine, and Ariel confirms as well. So maybe it's just Jorge.
Okay.
Yeah, sorry. Okay,
sorry. Don't blame the victim.
You forget you're speaking to an Israeli crowd.
Well, I won't say any Q&As. Maybe
them out, but yeah, maybe if we have more, we'll save it to the end, or else I'll interrupt you again.
Okay, that's fine. Yeah, I mean, I am happy to be more of a conversation. I do have kind of a hard stop in about 25 minutes. Yeah, but great questions to answer for sure. All right, well, let me kind of charge on then. So things to be aware of with JWT, above and beyond what we already talked about, what people have already asked questions about around like that, the data being public. Oh, and I should say, by the way, that you should always send JWTs over, except for in development, you should always send JWTs over TLS, right? And so that kind of obviates the worry a little bit about the public nature of JWTs, right? Because if you're sending over SSL, then you shouldn't, in theory, have to worry about it being seen by anybody else, especially if you only send it as a header or a forum post. Don't send JWTs as a query parameter, because those can get cached. Anyway, beyond that, also JWT or JWTs lets you have a none algorithm. And so what that means is that there's no signature required. And if you recall what I was talking about with signature, that's the way you validate that the JWT hasn't been tampered with as it's been sent over the wire. So what that looks like is you change this JWT and you just remove the red section. So there's no signature. There's still three parts. There's the header, the payload, but the signature is blank, is empty. And so what that changes in the header is it looks like this instead, right? So we have an alg of none instead of an alg of whatever the signature algorithm was. And that means that the payload can be tampered with. And obviously that's a bad idea. The specification allows this, and the reason why is the specification is trying to cover a lot of different use cases. And the simple fix is that you just don't allow none, and you can do that on a couple places. You can do that in the IDP, right? The user API that's generating the JWTs. And FusionAuth, for example, doesn't actually let you choose algorithm of none. We just don't allow that option. The other thing you do as a consumer of the API, if you ever see an algorithm of none, right, when you're examining the JWT after you've decoded it, you could just throw up your hands and say, hey, I'm not accepting this JWT, right? Go ahead. I'm going to give you a 404 or 403, whatever the right HTTP status code error is. And then I'm going to, force you as a client to go back to your IDP and actually get me a real JWT with a real algorithm. Now, of course, there's always a depends. There's always a but, because I am a consultant in the past life. There's always a depends. There are situations where using alg none matters, or is the right choice, and that would be if performance is very, very, very important to you, and you've benchmarked that, and you have another way to verify your clients. And so an example that would be mutual TLS, right? If the client's presenting a client certificate, then you probably know who that client is. Another example would be if you're building some high performance computing thing and you're on like an isolated network, right? Where you know who all your clients are and there's never going to be clients that are unauthorized. But in general, we recommend that you use a signature algorithm. And if you're in this kind of use case, or you're in this kind of specialized area where you might want to consider algorithm of none, you're probably not attending a basics on JWT talk at Israel.rb, right? I'm just going to be honest with you. So let's kind of step up and talk about different algorithms. So the nice thing about JWTs is that you can either sign them with a symmetric algorithm, which is what I showed you previously, or you can use public-private key, a public-private key algorithm. RSA, elliptical are the ones that I've seen supported. And so what this lets you do is it lets the to-do API and the user API be, as I kind of have telegraphed previously, controlled by entirely different organizations. And so that means that the user API can have this private key and can sign the JWT with the private key, pass that JWT down to the client. The client can present it to the to-do API, and the to-do API can have the public key and verify that user API signed it. And so that means that you have this kind of additional decoupling, right? It's not even just the decoupling of not needing to go ask the user API to say, hey, this opaque token, what does it mean? Who is this user this represents? It actually means that I don't even need to have a shared secret between them to be able to verify the signature, which is what the HMAC algorithm will actually require you to have as a shared secret. So the JWT, the to API retrieves the public key from a well-known endpoint. And this right here is a FusionAuth specific endpoint, but there's actually a standardized version. It's called JWTs, I think is the specification. And so it lives at a particular place on an identity provider at the user API. And the to API can go ahead and retrieve that. Now you will say, hey, Dan, I thought you said that this was totally decoupled. There's a little bit of decoupling. There's a little bit of coupling now, right? Because the to API needs to go talk to the user API for the public key, but that can, maybe happen once a day or something like that. Or it could actually happen whenever the to API gets a key that it hasn't seen before. Because the way it works is that this is the output of that endpoint. And if you have multiple keys, you can actually put the key ID in the JWT header, and then you can go ahead and pull that key from the endpoint. Basically that key will be stored in the endpoint. So you can see here 42 corresponds to the key ID of 42. So basically, if the to API gets a key ID of 43 and hasn't seen that before, it can go out and pull all the public keys from the identity provider, and then go ahead and parse it and see whether the JWT was signed with the private key corresponding to the public key. Refresh tokens are another piece of the JWT puzzle. So JWTs in general, because they're stateless, because they can be verified apart from the IDP, they are meant to be short-lived. And so, it's on the order of seconds to minutes. Refresh tokens, on the other hand, can live for a lot longer, days or months. And so basically, a refresh token can be presented to the user API to get a new JWT. Let's see how that kind of breaks down. So what might happen is the user might authenticate, right? The client might authenticate against the user API. the user API will generate a JWT, and it might say, hey, this JWT is good for 5 minutes or 30 minutes. And it will also generate a refresh token. And so the client will store both of those, and then it will present the JWT to the to-do API and go ahead and make those changes to to-dos, right? Add to-dos, delete to-dos, mark to-dos as done. And then at the end of that 5-minute period, the to-do API, when presented with the JWT that is expired, might say, whoa, guy, you're expired now. I'm going to give you a 403. You're unauthorized. And the client then catches that 403 and says, oh, I'm unauthorized for some reason. It could be because my JWT's expired. Okay, I'm going to pass my refresh token back to my user API. And then the user API says, oh, yep, this refresh token is still valid, and hands back a new JWT for another 5 minutes, which then the client can store and then pass the to API. So that's basically how you would use a refresh token kind of in this cycle. As far as deleting users, in a typical monolith, right, a Rails monolith, I should probably change this to be active record instead of SQL, but you would do something like this, right, where you say delete from users where, a given user ID, and you might delete from the to-dos where you have a user ID equals 42 as well. But if you are in a single database, you have cascade if you want, right? So you can say delete from the users where user equals 42 on delete cascade, and then all of the subsidiary data is going to be deleted as well. That's a problem in a distributed architecture. You don't have that option. So you have two choices here. The first is you can push everything to the client, and you can say to the client, hey, when you're deleting somebody, when someone's uninstalling their application from their phone, you need to make sure that you call every API and you say, hey, this user is deleting themselves. Go ahead and delete any data you have about this user. So that obviously works okay when you have 2 APIs, but if you have 3 or 4 or 5 or 6 or 10 or 20, it might be more problematic. So the other alternative is to have the client fire a single delete event and to have any interested APIs register to be told when a user's been deleted via webhook. And so in this particular case, the user API will send the delete user webhook to the to-do API, and then the to-do API is responsible for catching that and understanding what to do with it, right? So it might be archiving to-dos, it might be deleting the to-dos, it kind of depends on what the business logic is. But the nice thing about this option is no matter how many APIs you build, you only have, your clients only have one delete call to make. If you're going to build logout, you also want to be conscious about how JWTs work with that particular operation. With refresh, it's pretty easy to handle logout with refresh tokens, right? Because we basically just say, hey, delete this refresh token. So the user API is told about the logging out, and therefore that refresh token, if it's captured by somebody else or something like that, it can't be used to mint new JWTs. On the client side, we're going to delete the JWT, we're going to delete the refresh token. The issue is that JWT is still good for 5 minutes, right? So if someone logs out just after that JWT has been generated, there's still this 5-minute window that JWT could be used against the to-do API. And we'll talk about ways to deal with that in a couple of slides. Yeah, that's pretty much all I want to say on this slide. You do want to make sure that you log out of all the refresh tokens with a, if the client wants to log out, right? Because it's possible you could have multiple different IDPs, right? If kind of stringing together a bunch of services. So speaking about revoking JWTs, right? I mean, this is a case of you live by the stateless portable token, you die by the stateless portable token. Because JWTs are stateless, revoking JWTs is kind of iffy, right? Because the fact that you don't have to go back and talk to the IDP to verify that a token is valid means that you don't know if someone has logged out and marked that JWT is should be invalid in the future. So let's say that a user's account has been breached. Not a good thing to happen. Usually, we don't really like when other people can act as a given user in our systems. So if that happens, you have a couple options. You can rotate your keys, and this is definitely a solution. It is kind of a burn the house down kind of solution because depending on which kind of algorithm you're using to sign, you could be invalidating a lot of people's keys. It's definitely not going to be targeted unless, and I guess this is a possible solution, you could create a public key per user, right? If you create a public key or public-private key pair per user, then you could invalidate just that user's key pair. But if you, that's kind of, that might be an interesting thing to write on. I haven't actually thought about it before, but typically you're not doing that. And so you're going to have a kind of a wider blast radius than you would if with some of the other solutions. The other thing you can do, not the time window solution, but another thing you can do is just wait. And some people do wait. And they just say, I'm going to accept that this 5-minute window of my, someone possibly hacking and finding my JWT or my JWT or a different user's JWT. It's an acceptable risk for me for this trade-off. The other solution is this time window solution, which basically the same way you register for a user delete event, you can also register for a refresh token revoke event, which is basically a logout event. And so when that happens, you can notice that this user is logged out, and then you can basically, if you get a JWT from this user during this time period, you can say, I'm going to not accept that as valid. So you're reintroducing some state because obviously you need to have some kind of caching mechanism or some kind of way of keeping track of the fact that this JWT has been revoked. So this gets us back to kind of maintaining more state. And we talked about, pushing, the benefits of JWTs being that they don't have state. This is a trade-off that you're going to have to make when you're thinking about building logout functionality, basically. So let's kind of talk through this time window solution a little more. So let's assume it's May 9th, 2020 at this particular time, and that's when our breach event happens, or when we're notified of our user's account being breached. So that, and if we have 30 JWTs that last for 30 minutes, that means that a JWT created right now at this breach would be, I'm sorry, this is not when we've been notified of the breach, it's when we have fixed the breach. So a new JWT created right now will expire at 1:42:47 because it's a 30-minute window. That means the JWT created 1 second ago before we had fixed the breach issue, right? Change the user's password, however we fix the breach issue, will expire at 1:42:46. And so that means that any JWTs that have expired before that time are JWTs that we do not want to accept because they were generated before we fixed the breach. So basically what we're doing here is we're dealing with this red area, right? This is the time that JWTs will expire that possibly could have been created by a user account that was breached. I'm going to do the code really quickly here because I want to have a little time for questions. Share screen. Oh, wait. There we are. Wow. So this is all, this is a repo that I have a link to in the presentation. I actually will show you, and it's open source. And so this basically just shows you using a great gem called the JWT gem or the JWT gem, you can build JWTs. And so here's an example. We have the HMAC secret. So this is using the symmetric signing algorithm. We have an expiration we're building. Here's our payload. And we encode this payload. And so this is all like lines 3 through 19 are all what would happen on the user API side. Typically, you're not going to be generating JWTs as a Rails developer. You're much more likely to consume them. But I think it's always interesting to like see how they're built. And then here's the line 20 through 24, is the decoding of it. And so here you can see that we have to have this shared secret. And we have to specify which algorithm the JWT was signed with. So let's go ahead and Ruby build. So you can see that we've generated out this JWT and that we've decoded it and turned it into this payload. And I want to look at one more thing, verify additional claims. So here is using this, the previous example I showed is not great because the only thing that the Ruby JWT gem actually validates is that the JWT is not expired. And so here we actually want to do more than that, right? We want to verify that the issuer is who we expect it to be. And so this actually, if I run this, it should fail because my issuer on line 8 is not the same as my expected issuer. So this deals with the possible situation of someone else stealing the HMAC secret and not knowing which issuer to provide. If I do Ruby, and I see a question there, so I'm just going to do that real quick. Do this real quick and then address the question. So you can see this this throws an error. So that's good. And so again, you should check your audience, you should check your issuer, you should check your expiration time. There's actually something called a not valid before time you can check as well. So you can issue a JWT. I could conceivably issue a JWT that was valid for 10 hours from now to 10 hours and 5 minutes from now. So Ariel says, in a solution where, so Ben asks, why would you construct a JWT with no signature? Again, that's a case where you are concerned with the impact that, I mean, obviously signing something cryptographically takes longer than not signing something. And so if you are using JWTs in like a high performance use case, right, like financial transactions or something like that, or computer, calculations, scientific calculations, and you can also verify that people and you're not worried about people creating additional JWTs that are kind of any malicious actors, that would be a case where I would use a signature of none. Again, it's a kind of very super specialized use case. And then Ariel asks, in a solution where all JWTs from before time X are invalid, do you have a recommendation on how to update that time in an efficient way? I'm not sure I understand that question. I would think that you want to update that time in an efficient way. Yeah, I don't understand the question. I'm sorry. I don't know if you want to rephrase that or hop on and ask it in person or.
So I was hopping on just because I was waiting for Ariel to kind of follow up. He says, since all servers need to be updated with that info, that all servers need to be updated.
Right. Yeah. So like the To-Do API, like all the servers that serve the To-Do API might be. I mean, I'd probably store it in something like a Redis, right, or something that's like a memcached, where it's like a in memory database, because it's not going to matter in 5 minutes or 30 minutes anyway. So I don't think you need like a persistent database to store the fact that
I think it kind of does, because he also followed up. He said, and you don't want to create a DB call per HTTP request.
Yep. So yeah, so we actually have implemented this pattern. You can go to FusionAuth and check it out. We actually do that with just an in-memory cache. Um, and everybody, all the to-do APIs get the webhook, right? So if you have 5 to-do API servers, they all register for the webhook and they all get that revocation event. And so they all update their own in-memory cache, would be one way of doing it. Or you could have one, you could do it if you were concerned about that additional complexity. You could put it all into a Redis instance and have everybody kind of check that level of cache. But again, I would also say I don't think you need to be super worried about this, because how many times are people logging out where this you need to worry about this versus the normal JWT cycle where it's a lot more like kind of like the refresh token is called, you get the new jot. People tend to have longer lived sessions than 5 minutes. Well, I guess that depends on your application's use case, but that's what I would expect. Yeah, cool. Well, let me turn through the last couple of slides.
I know you said you had a hard, you had to
we'll
be finished at the hour. We're right at the hour, so just keep that in mind.
Yeah, thank you. I'll make it quick. Yeah, I think I got another couple of minutes I can squeeze out here. So as far as jots and rails, I think the question is, what are you trying to accomplish? If you're trying to generate jots, then you probably want to use the jot gem. I have, done a little bit of performance testing on that. It doesn't seem that the performance impact is probably more based on what algorithm you choose than using Ruby. Again, you're probably not going to be generating jots very often. If you want to use authorization, you can use a before filter that examines that jot, consumes it, looks for those claims. There is device integration. I have not played with that very much. And then someone else pointed out to me that there's this cool gem called knock, which is if you don't want to hand roll which you probably shouldn't, if you don't want to hand roll your own jot parsing, you can use that, and that actually kind of plugs right into your APIs and takes care of that validation of jots when a jot comes in to verify the audience, the subscriber, all those pieces. JWT tools, again, there's a debugger here. That's one of many. There's probably 20 out there. Just to give you an example, the code I showed you is available on GitHub, Apache license. And then I wrote a post about how to build a secure jot and the different ways, all the kind of different considerations you need to think about when you're building a jot or consuming a jot. And then thank you very much. Here's my contact information. And I could probably take one question if anyone has a question. Otherwise, I really appreciate y'all having me on, and I'm really excited that you all are kind of kickstarting the Ruby community in Israel. I host the Boulder Ruby community, I'm a co-organizer, and I would say it's been a tremendous experience for me.
Thank you so much, Dan.
So
I want to say thank you too. It's kind of an interesting time we have right now where I sent you a follow on Twitter, so see when the next Boulder meetup might be, and we're locked inside our houses anyway. Might as well see what's going on in Ruby worldwide. If you don't, a lot of the questions from my perspective were a little bit more advanced in the weeds. So if you have time, if you don't have time, feel free to leave. But just so as more of a kind of early career developer, I've always, as far as for Rails authentication, you add devise. When I guess the question I have is, at what level is throwing devise on there and then kind of forgetting about it? When you need to start thinking about implementing more robust, I guess, security and looking to reach out to Dan at Fusion and have you come and add maybe some more high level jots and whatever security features we need to know.
Sure. So it's a great question. So, first of all, devise is 100% great, right? I've definitely built applications that leverage devise, and it's super solid. I mean, to me, where it starts to make sense is where you start to think about one of two cases. Either you have other applications that you want to like layer on the same security model. And so an example I have that we actually have at FusionAuth is we have multiple different applications. We have a form application, we have like a customer application, we have customer support application. We use Zendesk, and so all those can authenticate against a single user database, right? Which makes sense to have one place where if someone comes on, we hire someone new, we just add them in one place. If someone leaves, we remove them in one place. The other case is where you're starting to build your Rails app is getting big enough where you can start to like break out pieces, and that doesn't necessarily even need to be into microservices, right? Because very big companies have built very big monoliths with Rails, but it could even just be like you want some kind of like team separation, right? And so you want to have kind of a view where it's more enforced. And so in that case, you might have, I mean, I know Heroku did this. That was one of the first services they pulled out was like a user service. And then even other, all the other applications, even though they were all written by teams in Heroku, still use that user service and had like these guarantees, this contract with this additional service. And that could have been FusionAuth. It could be like their own local thing. If it is your own local thing, you still might want to use something like JWTs because new developers coming in will know about them and their characteristics rather than kind of trying to understand the Heroku way to do authentication. And then also there's libraries you can leverage, right? So that would be my short answer. I don't think someone starting out a startup, who's like banging out code or, a 2 or 3 person team benefits unless, of course, you're going to have other additional applications and you want to kind of even just commercial off the shelf stuff can integrate with a user management system. Does that make sense?
It makes a lot of sense. So I don't see any other questions, but again, I just want to say thank you from myself and from our whole community here. We're going to do 10 minutes back on the tables. So see everybody on the tables. Thank you, Dan. Bye.
Okay. Thank you all.